Now, I am continuing from my previous lecture that let us draw such a triangle whose three sides are taken in the same order and represented by the vectors A, B and C respectively. The angle between the vector A and B, it is theta 1, and that between B and C is theta 2, and that between C and A is theta 3. Okay. Now, according to the sine law of the triangle, that the ratio of the particular length of the side of a particular triangle to the sine of the opposite angle of the triangle must be constant. That means modulus of A, this is the length of the side represented by the vector A, by sine of the opposite angle of the triangle, that is sine theta 2, equals to modulus of vector B by sine theta 3 equals to modulus of vector C by sine theta 1. Okay. Now, so using this relation, the ratio between any two sides of the triangle can be simply computed in terms of the sine of the respective angles. Okay. Now I am again repeating at a or concentrating at a particular thing, that the angle between the two vectors in physics should be taken that angle such that the two vectors from the particular point appears to diverge from the point. For example, let us see that the angle between the vector A and the vector B, it is not 180 minus theta 1, but it has been taken as theta 1, because from this point the vector A appears to be directed along this direction and the vector B is along the direction. So from this point the two vectors A and B appears to diverge. So this angle should be taken as the angle between the two vectors. Now, using the sine rule, we can solve simple problems related with the triangle law of addition of vectors. I am just giving you an example. Say two forces, one is 2P, another is P, are added to get a resultant. Thus, clearly the larger force is 2P, the smaller force is P. So, it is say 2P. It is 2P and it is P. So, if we apply the parallelogram law of addition of vector to find out the resultant of the addition of these two vectors, then according to the parallelogram law, it will be the resultant, it will be the direction of the resultant. So, it is R. Let the angle between P and 2P, it is theta, and the angle that made by the resultant with the larger vector, it is say phi. Okay. Now, clearly, this side will also be represented by the vector P. Now, I am concentrating on the particular triangle. Say, I am taking this triangle. Okay. Now, from simple geometry, this angle is theta. So, it is 180 degree minus theta. And what will be this angle? It will be theta minus phi. Okay. Now, applying sine rule of triangle, we have, that is the ratio of the particular side of a triangle to the sine of opposite angle of the triangle must be a constant. So, P by sine phi, it is P by sine phi, it is R by sine pi minus theta. It is equals to 2P by sine of theta minus phi. I have written in the scalar form. Now, using these two ratios, that means P by sine phi, it is 2P by sine theta minus phi. Let theta minus phi, it is another angle, say phi dash, that is 2P sine phi dash. Therefore, sine phi, it is P by 2P into sine phi dash. Okay. Now, for all possible values of phi dash, sine phi dash will be less than equal to 1. All possible values of phi dash, sine phi dash will be less than equal to 1. Therefore, sine phi must be less than equals to half into 1, because this is simply half. Okay. Or phi dash must be less than equal to pi by 6. That is the maximum angle that the resultant can make with the larger vector, that is 2p, will be pi by 6, or the angle made by the resultant with the larger one must be less than pi by 6, or its maximum value may be equal to pi by 6. Okay, up to now.